Hello everyone, this is Rohan Meshram and welcome to today's video where we will explore AutoDock Parser, a software developed at my lab. And this AutoDock Parser is a user-friendly standalone tool designed to simplify the post-processing of molecular docking and virtual screening result. Before we dive in, let's understand its significance. Molecular docking and virtual screening undoubtedly are pivotal in drug discovery, and AutoDock has emerged as one of the preferred open source tool. However, the post-processing steps have often been complex and time-consuming. Today, here we introduce AutoDock Parser that is going to address these challenges in post-processing. Let us have a brief overview of various workflows or protocols that are generally used in post-processing the AutoDock result. So at the end of docking or virtual screening, user generally have output files in case of it can be DLG in case of AutoDock, or the output file can be in form of a PDBQT file if you are using AutoDock Vina. So let me show you how exactly the AutoDock output file looks like when it comes to using AutoDock. In our case, we would be stick on to AutoDock output. As you can see, this AutoDock gives output in form of this docking log file that has an extension .dlg. So these docking log files contains the poses that are predicted during docking. Let me show you as to what exactly it is there in this DLG files as such. Right. So what you can do is that if you are using Python prescription, you can use this button over here that is used to load the docking log file. It says load docking log files. Just click over here and just browse to the place where your docking log files are located. Just click it and open it. So now as you can see, there are different whatever poses that are there that has been predicted. Well, these are recorded in these docking log files. So for subsequent interaction analysis, we need these predicted poses in complex with its receptor protein. And my friends, here is where things start to get complicated. So let's first walk through some basic workflows or protocols that are generally followed when it comes to generate the protein ligand complexes, starting out with the poses that are recorded in a docking log file or PDBQT file when it comes to AutoDock. So let me show you that if you are using Python prescription as I have shown, then you might end up with output files like a docking log file or PDBQT file if you are using AutoDock Vina. So the very first step that is needed to be done is that whatever the 10 poses or multiple poses that are generated during molecular docking, those are supposed to be exported in a separate file, and Python prescription usually exports all of these poses in a single SDF file. What you need to do next is that depending on what is the pose that you are interested in, you would select the best pose. The best pose is usually the one which is having the lowest binding free energy that the poses has been predicted. Okay, so once you separate the best pose out of the different poses that have been predicted, the next job is then to use text editor to convert your PDB to convert your SDF file into PDB format. And for this conversion, usually another external software is used. One of the most popularly used software is OpenBabel. So using OpenBabel, now you can convert your SDF file into PDB file. And once the predicted pose is present in PDB format, you usually have the receptor protein in PDB format. Next, what you do is that you merge the predicted pose with that of protein, and it is also done in say some text editor like you can use TextPad, you can use Notepad++, you can even use Notepad, and finally you generate the complex. And the finally generated complex is later on visualized in any visualization software like Lickplot or PyMol or Rasmal or whatever it is. So the major limitation of following this kind of workflow is that it relies on multiple software. Well, say for example, you would have to work with Python prescription, you would have to work with text editor, you would have to work with OpenBabel, and of course there are multiple steps that are needed to be followed, and a lot of work is needed to be done manually. So you can say that these are the limitation when it comes to do post processing of molecular docking results using Python prescription. On the other hand, if you are using AutoDock tools for post processing, then in that case you might begin with the DLG file you have, you might have the receptor file in PDBQT format. What you usually do is that you load both of these file and then go to this analyze menu, and in confirmation submenu you select display or ranked by energy. This will bring another this will open up another windows, and in this window there is a button in which you can play or visualize the rank by energy. So this is what will show up when you use this play and rank by energy button. So another dialog box will open, and in this dialog box, using this write complex button, you usually save the complex in PDBQT format. But most of the software requires your protein ligand complex to be present in PDBQT to be present in PDB format rather than PDBQT format. And therefore people usually use this OpenBabel software to convert the protein ligand complex in PDBQT format to PDB format, and eventually later on they visualize in any visualization software like PyMod or even Discovery Studios as such. So the major limitation of following this workload is, of course, you need to play around with multiple softwares. The procedures appears to be lengthy and lot of manual work is needed to be done over here. Another or third most popular workflow that is generally used in post processing involves two script that can be downloaded from MGL laboratories GitHub page as such. Okay, so there is a there is a Python file called as write all complex.py. You can download this Python file from the GitHub page of MGL laboratories. So what this Python file does is that it takes input the docking log file or the receptor file in PDB format, and it generates the protein ligand complex in PDBQT format. Then there is next Python script called as pdbqt to pdb.py that converts the output pdbqt file into protein data bank format that you can later on visualize in any softwares like Vega ZZ, SPDBV, or your any preferred visualization software for interaction analysis. Other way around is that again you can use OpenBabel to convert this PDBQT file into PDB file and then of course visualize in any visualizer. So the major limitation of using this Python prescription script is that it has got this script has got dependency on molkit module. You need to use multiple software. There are multiple steps of course that are involved. A lot of things has to be done manually, and of course you might require some programming background in order to configure the Python script that you are using. These are some of the workflows or protocols that people generally use for post processing the docking results, right? So all of the softwares that I have mentioned in these three workflows or these three protocol, these are needed to be downloaded and installed separately. They are needed to be configured correctly for their successful application. And this kind of support and guidance is usually not there with beginners who have just started to work in molecular modeling. So our idea is to come up with a solution that minimizes these efforts, shorten the workflow, and reduce the manual work. And in this way, we here present AutoDock Parser that generates protein ligand complexes just in a single step. So now let me give you demonstration of the utility of the softwares that we have developed. Okay, so now let's demonstrate how easy is to use AutoDock Parser. All you need to do is to go to any web browser, and you can search simply with term like AutoDock Parser. So the second link that is followed, that will follow you to the SourceForge website, this is the one that you are supposed to follow. Just click on this AutoDock Parser download link and it will take you to the SourceForge website. And on the SourceForge website you can download our software from this files tab, and just click on this AutoDock Parser.exe, and your software will get downloaded. So once you have downloaded the software, I have already downloaded it, I will show you as to how it will look like. So after downloading, this is how the software would look like. It is an executable installer. All you have to do is to double click on it. Once you double click on this software, or you can say the installer, all you need to do is to follow the instructions that are present in its installer. Just click on next, and the software will be installed once it is finished. So I have already done this thing, so I will not do it once more. After successful installation, you might end up with an icon that might look like this on your desktop, right? So now if you, after successful installation, when you open this AutoDock Parser, it generally opens in the main window. So over here, the first thing that you need to do is to first set your working directory where all your input files are located. So to do that, all you have to do is to go to this file and use this set working directory, and then go to desktop. In our case, I have kept all my files, whatever input and output files will be saved in this demo directory. So this is our working directory. I will click on this working directory to select it, and then select folder. Now you have set the working directory. Next thing that you need to do is that you are supposed to locate the pdbqt file. Go to this demo. This is your docking log file. Select it. Select the receptor file. This is the receptor file. Open it and just hit this get complex button, and with these three simple steps whatever poses that were predicted in your DLG file, those are now present in complex with your protein molecule. Now you can easily open those in any visualizers like SPTBV, and simply here you go. You have your predicted poses in complex with its protein in just 3 steps, right? So here is the predicted pose, and here is the protein in complex with its inhibitor. Okay, so with these 3 basic steps, and your post processing is done without any manual intervention. So in conclusion, AutoDock Parser can emerge as a powerful tool, which is of course user friendly in the field of molecular docking and post processing. Its streamlined approach, simplicity, and independence from extensive programming background can make it a valuable asset for both experienced researcher and newcomers in this field. Now I would like to thank Arjun Yadav and Asad Ali, two of my very gifted MSc students, for their tireless efforts to make this software happen. So you guys rock. So thank you for joining us today. If you use this software in your dissertation, thesis, or research paper, please cite our research paper that is present on the SourceForge website, and that will of course improve our morale and help us acquire funding to improve this software. And of course, if you found this video helpful, don't forget to like, share, and subscribe. So until next time, happy docking.